problem set. In this problem, we're going to add a node to anywhere in the list. Anywhere. You just need to give me the index. So giving an index and the value, add the node. So again, following from previous tutorials, if the value is 5 and the index is 1, position 1. So this is position 0, position 1, position 2, position 3. So I'm going to add the 5 here. That's what the given index is. So here's the 5. So you're going to have node 1, then 5, then continue. Oh, then this would be node 2, sorry. And then this would be node 3. And then you have node 4 as well. Basically. And then you have node 4 here. And then you have node 4. So I created a bunch of stuff here so I can explain how we're gonna do this. So like the previous tutorial, we're gonna create a copy to the head, and then we're gonna traverse the copy. But before we start to traverse, we're gonna create a copy to the copy. So we're gonna call this one current. So this is gonna be our current pointer. That's gonna point to the same thing the copy is pointing to. And then we're gonna create a pointer called next. That's gonna point to the next thing the copy is pointing to. So current and then next. And so whenever we traverse the copy, these three will traverse together. So for the first node, we're going to ask ourselves a question. Before we traverse, we're going to say, is the index 0? If the index is 0, then we need to do our changes here. But in this case, the index is not 0, it's 1. So we're going to move all of these guys to the next one. Right there, like that. Now you can see we have position 1. Is the index 1? Yes, it is. If the index is 1, well, what we're going to do is this. We're going to say the current's next. So the value, so the node that the current is pointing to is node 2. So we're going to say the current's next is going to point to the new node. So we're going to say the current's next is going to point to the new node. So this will point to this. And then we're going to say the new node's next is going to point to next itself, which is this. And then that's it. So let's do that. So we're going to say, we're going to call this add node to index. Now this is going to take the head as usual. The pointer type is going to take a data. This is the node type, and it's going to take an index. Now the first thing, let's create our new node. New node with the data. This is the 5 that we're making the new node. And then, like always, we always want to check, is the head null? If this is null, right, then we know what to do. Head equals new node, because it's empty, and then return the head. If it's not null, we're going to start creating our copies now. So we're going to create our copy to the head. Now, because a list is not an array, we don't have access to the index value. So like in an array, when you do a for loop, you can access the array. You have random search. You don't have that with a list. So we have to keep track of the count ourselves. So we can say let count equals 0, right, to count the nodes. And then we can say, let's start by saying if index you give us, if it equals count, so if it's 0, so we want to check if the change you want us to make, if it's at the beginning of the list. Beginning of list. If it's at the beginning of the list, that's fine. So we'll say head equals the new node, because it's at the beginning of the list. The new node next equals the pointer. That's it. And then we'll return the head. That's if it's at the beginning of the list. If it's not at the beginning of the list, that's fine. That's even better. If it's not at the beginning of the list, we want to traverse. So if it's not at 1, if it's, let's say the index is at 2 or 3 or whatever, we want to traverse. So we'll say while the copy exists and the next exists. This allows us to stop the loop once we approach null. If the next value is null, break the loop. That's what this is saying. So let's increase our counter, and then we're going to create a current pointer, and we're going to create a next pointer like that. So this is the current that I'm talking about, and the next right there. We're going to ask ourselves a question: is index equal to count? If index is equals to count, when that happens, then current next equals new node, and new nodes next equals next itself, and that's it, and we return the head. Now in some case, oh, we have to traverse, don't forget to traverse. Now we're traversing. Now in the case if where you want us to add, so this is the beginning of the list, this is somewhere in the middle, what about if it's at the end of the list? End of list. We have to remember that. So by the time we get out of the loop, if this condition is never met, that means we are at the end of the list. Then all we have to say now is pointers next value equals new node. That's it. And then we return the head. And that's it. This will solve it. So let's test this out. Add to the index. So let's see what's our list looking like so far. We have 0, true, false. So I'm going to add it to where true is. I'm going to move true and then add it to position 1. I'm going to add a string there to position 1. Add node to index, head. I'm going to add hello, a string, and then position 1. All right. This, the output of this, so instead of true, after 0, you see the string hello, and then after hello, you should see true. Let's test this out. Compile, execute. Let's see. There we go. So you have 0 here, and then you have hello, and then you have true. So 0 is first. Remember in the previous one, you had this. Now you have 0, hello, and then you have true. See you in the next video.